I have this one friend, and I swear I am constantly forgetting his specific food allergies.
Oh, no.
Yeah, so I always have to like dig through old text messages just to remind myself before we go out to dinner. And it's so frustrating. But, that is exactly what we do with current AI, right?
We really do. We
Yeah.
just constantly have to remind it of the context.
Right. Every time you prompt an LLM today, it's like dealing with an amnesiac. You have to brief it all over again with external text. So today, your mission is to explore how AI is finally evolving past that.
Yeah, we're looking at this fascinating paper from Mentensor and their partner universities about a prototype called Metis.
Metis, which is essentially giving AI its own internal native memory. I mean, if you've ever built a RAG pipeline, you know the struggle.
Oh, absolutely. Retrieval augmented generation.
Yeah, it's basically like having an assistant who has to pause everything they are doing, run across the room to a physical filing cabinet, pull a document, and then come back to answer your question.
It is very sequential.
Yeah.
And really, really slow. And technically speaking, that pausing creates what we call blocked gradients because that retrieval step is discrete. You are just pulling a chunk of text from an external vector database, so the learning signal just gets completely cut off.
Wait, so the model literally can't optimize how it stores or retrieves that data?
Right. It can't use backpropagation to optimize the memory end-to-end. It treats external data as a hard input, not a fluid part of its own neural pathways.
Which brings us to Metis, because the researchers fixed this by introducing a native memory state and a procedure directly inside the model's backbone.
Yes, the memory is processed autonomously right alongside normal computation. The gradient flows uninterrupted.
So it's not an external dependency anymore.
Exactly. It's a dynamic part of the model's own internal weights.
That is huge. And hey, speaking of optimizing and finding where AI agents can actually make a real impact, I do want to quickly mention our sponsor.
Oh, right. Embersilk.
Yeah. If you need help with AI training, automation, or software development for your business, you definitely need to check out embersilk.com for all your AI needs. They are fantastic.
They really are.
But okay, getting back to Metis, I have to push back a little on the efficiency here.
Sure, go ahead.
If it is internalizing all this data natively, won't it just, run out of space? I mean, doesn't the parameter count just explode and slow everything down to a crawl?
Well, you would think so, but it actually avoids that bloat through these things called Metis blocks. They divide the workload into local and hypermemory blocks.
Okay, so how does that keep it from infinitely expanding like some massive Word document?
Because instead of just appending new data, Metis uses a single forward computational pass to compress historical information mathematically.
Wait, mathematically?
Yeah, it compresses it into fixed size parameters. The hypermemory blocks synthesize the high-level semantic concepts.
Oh, wow. So it's not storing the raw text of a memory at all.
No, not at all. It's essentially calculating the semantic essence of the new information and blending it in. And because it's just updating fixed parameters in that single forward pass, it operates entirely gradient-free during live updates.
Meaning it's incredibly parallel and fast.
Exactly. Very fast.
That is wild. But because all that memory is getting squished into a compressed parameter space, I did notice a really strange quirk in the paper's data.
You mean the unlearning problem?
Yes. Even for their massive Metis 27B model, the hardest task wasn't learning new facts, it was forgetting them.
It is physically harder for this architecture to unlearn a specific fact than to learn a new one.
Which sounds crazy at first.
It does, but it's a direct consequence of that compression. When you mathematically blend the essence of multiple facts into shared parameters, you can't just isolate and delete one single fact.
Right, because you risk damaging the entire semantic web of everything else stored there.
Exactly. It's a challenge they are still actively managing, but honestly, the implications here are profoundly optimistic.
Because we are finally moving away from AI just being a stateless predictor.
Right, a machine just guessing the next word. Now we are shifting toward a true stateful learner. Digital intelligence is becoming capable of continuous organic adaptation.
Which leaves you with a fascinating question to ponder. If AI can now natively remember, reflect, and just continuously evolve from every single interaction with you without you ever needing to jog its memory manually, how might that transform our standard digital tools into true, lifelong creative companions?
It really changes everything.
It really does. Well, if you enjoyed this podcast, please subscribe to the show. And hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.